A piecewise function is just a function that's represented by a combination of different equations, each one corresponding to a different part of the domain. Okay? And a piecewise function is going to look like this. It's going to be function notation, but instead of it equaling one single equation, it's going to or one single expression, it's going to equal different expressions based on the number that you're plugging in or evaluating for. Okay, so in this case, I'm giving you a piecewise function with 3 different possible expressions, depending on what values you choose. Okay, you're also going to get a domain interval that identifies when you're using specific expressions. And then lastly, you're going to be asked to evaluate it. So they may ask you to solve for f of minus 1, f of 0, f of 1, f of 2, and let's say f of 3. If you're being asked to evaluate each of these, the way that you're doing this is you'll plug in your value based on whichever domain interval is identified. Okay, so this is the condition. These will be conditional functions, okay, based on which interval that you use, and then you're going to evaluate it into the designated expression. And the expression you use is based on the domain interval or the condition that's applied. Okay, so for f is or when you evaluate f of negative 1, okay, so negative 1 is your x value. Which of these expressions will you use for f of when x is negative 1? The top, the middle, or the bottom? So negative 1 falls in which of these intervals here, domain intervals? Top one. So you're going to use 2 times x plus 3. Remember, in the function notation, x is just a placeholder, so I'm going to represent that with this open parentheses, and then you just plug in your number here. So 2 times a negative 1, you get negative 2 plus 3, or you get your answer of 1. Yeah. Okay, what about 0? Matt. Thank you. All right, so what about x is 0? Which of these expressions will that domain interval fall in? Is it the top one or the middle one? Middle, because it has this less than or equal to. So when it's actually equal to 0, it goes into the middle one. So our expression is just a 2. There is no placeholder necessary. The answer is just always going to be 2 for that. Okay, what about f of 1? Where does 1 fit? Which domain? The expression on the top, middle, or bottom? The middle one, 1 is still within this domain interval. So we again get just the number 2, no placeholder necessary. Okay, what about f of 2? Okay, so here 2 falls into this last category. It's greater than or equal to 2. So we're going to use the expression negative x plus 1. Again, in that function notation, the x is just a placeholder. So I'm going to use the parentheses, substitute in what it's holding the place for, the value of x. So we get negative 2 plus 1, or we get an overall value of negative 1. And then finally, f of 3, the x value of 3 is in this bottom expression as well. So negative x plus 1, again, plug in your number. You get negative 3 plus 1, or negative 2. And does that kind of make sense how the piecewise function works? Okay, I want you to try this one on your own here really quickly. So when you look at this first example, you're evaluating when x is negative 2. Which of those intervals does it fall into, the top or bottom? Negative 2 is less than 5, so you're going to use the top equation. 3x plus 2, x is a placeholder. simply plug in your value for that, and then simplify, and you get your solution. Okay. Plug in 0 for the next one. Which interval does 0 fall into, the top or the bottom? 0 is still less than 5, so we're going to use 3 times x plus 2. Plug in our placeholder, so we get a value of 2. And then finally, the 5, does that fall into the top or the bottom interval? Now it's greater than or equal to 5, so at that point we switch over. -2 times the placeholder value, which is 5. And if we evaluate that, we get our solution.